Okay, so I'm going to clear out these directions. And let's start working our way through these problems. So the first one, number 1, we want to solve this for x. What do I need to do to get the x all by itself here? Subtract 35 from both sides. And so that would give me that x is equal to what? 55. X equals 55. Why did we subtract 35 from both sides? To get the x alone. We wanted to make this 35 over here cancel out. So when I do 35 minus 35, what number does that actually give me? 0. So then I have 0 plus x. Well, nothing plus x is just x. So I'm using the subtraction property of equality here. If you do it to one side, you have to do it to the other side. This is on that warm-up page, that white piece of paper that I handed you. Number 2, what would I do to get the x all by itself? Add 34 to both sides. This time I'm not using the subtraction property of equality. Anybody want to take a guess at what this one's called? The addition property of equality, yes. So I get x is equal to what this time? 180. Nice work. Number 3, do I need to add or subtract? Divide. Why are we dividing? Multiplication. Whenever you see a letter, a variable, and a number smashed together with no operation symbol in between, those things are being multiplied. So I want to make that cancel out. The operation that undoes multiplication is division. What is 3 divided by 3? Sorry, I asked a different question than you guys were expecting. 3 divided by 3 would give me 1, so I'm left with 1x over on the left. 1x is the same as just x. And then 180 divided by 3 tells me the value for x, and that is 60. There we go. So x is equal to 60. Last one in this section, I have negative x over 3. All right. So we're going to multiply both sides by whatever's in my denominator. In this case, that's a 3. If I multiply both sides by 3, is that going to take care of that negative sign out front? So I'm going to have a negative x. How do I get rid of the negative out in front? How do you take something from being negative and turn it into a positive? Hold on, let me see if my board's going to cooperate. There we go. Okay, so if I just do this, I would have negative x equals, what's 17 times 3? 51. When you see a negative in front of a variable, there's multiplication happening there. That's really a negative 1 being multiplied to our variable. So if I have a negative 1 multiplied to my variable, how can I make that cancel? Positive. How do I make it become positive? What divided by what would give me a positive, or what times what would give me a positive? Negative times a negative, or a positive times a positive. Or sorry, negative times a negative, or negative divided by a negative would give me a positive. So I can divide both sides by negative 1, or I can multiply both sides by negative 1. Either way, I'm going to make that negative cancel out over here on the left. What's 51 divided by negative 1? Negative 51. There's my final answer for number 4. Are you with me, sir? Okay, all right. Last one on the warm-up. Russia, the largest country in the world in terms of area, occupies 6,592,800 square miles. The difference in area, difference means what operation? Subtraction. The difference in area between Russia and Canada is 2,740,991 square miles. Write and solve an equation to find the area of Canada. Which one's bigger, Russia or Canada? Russia. So if I'm setting up my equation, I need Russia minus Canada, bigger one minus the smaller one. What is the difference between those two when I subtract them? This one comes from the problem up here. When I subtract Russia minus Canada, what is the difference between those two? It's coming right from this problem up here. Yes, 2,740,991. Do we know how big Russia is or how big Canada is? Do we know the size of either one of those? Here's that 2,700,000. Did they give us another size? Yes. That 6,592,800, that's the size of which country, Russia or Canada? Russia. So I'm going to take this number right here. I'm going to put it in the place of where I have Russia. 6,592,800 minus, are you guys okay if I just use C for Canada instead of writing it out? All right, so minus C equals 2,740,991. I want to get the C all alone. I want Canada all alone. Subtract. What am I subtracting? The Russia size. So minus 6,592,800. If you do it to one side, have to do it to the other side. So minus 6,592,800. Cancels out on the left. What do I still have in front of the C, in front of Canada? I still have a negative, so I have negative Canada equals, what happens when I take 2 million and I minus 6 million? It's going to be a negative. Negative how much? If somebody has the digits on a calculator, you don't have to read it with the millions and thousands, just read the numbers off for me. I heard 3, and then what were the next several numbers? 851809. All right, so I'm going to bring my work over here. I have negative C equals negative 3,851,809. How do I get rid of the negative in front of C? Divide both sides by -1, just like we did in the problem up above. I'm going to divide both sides by -1, and so we get that Canada is equal to a positive 3,851,809 square miles. That is not the only way to set up and solve that problem. But I do want to point out that the problem itself says that you needed to write an equation. So if all you had off to the side was 6 million something minus 2 million something, that's not writing out a whole equation. You get the correct final answer, but you missed the part of the problem where it asks you to write an equation there. Do you guys have any questions for me on the warm-up? All right, page 19 in your books, please. Page 19. Friday and yesterday, we talked about 3 geometric objects. Do you guys remember what 3 objects we talked about? It was points, lines, and planes. We're going to add a new geometric object today. We're going to talk about line segments today. Where do lines stop? Never. Lines continue forever in both directions. Line segments do not continue forever in both directions. Line segments have ending points on either side. When we name a line segment, you can't just pick any points on that line segment. It has to be the 2 end points, so I know where the boundaries are of that line segment. the way we will do our notation for line segments. We're going to have our two endpoints. We're going to have a dash over the top of it. No arrows this time. Arrows for lines, dash for a line segment. So if I have a line segment that looks like this, it does not continue on past those points, and I name it with those two end pieces. Again, order doesn't matter. I can switch those two around as long as I have the ones that are on the ends. Whoop, excuse me. These are called our endpoints. Are those the only 2 points on that line ever, or on that line segment? No, there's an infinite number of points in between. We just don't draw all of those other points, but there's a ton. There's an infinite number of points in between. We just use the two that are the end pieces, that are the boundaries when we name that. All right, now we're going to talk about something that's really, really important in this class. It's called betweenness of points. In this little space right here, I want you guys to draw this figure. We're going to have line segment AB. Between those two endpoints, somewhere on that line segment, it doesn't matter where you put it, we're going to put a third point. We're going to call it C. If A, B, and C are collinear, and C is in between those two endpoints, then I can take segment AB, so AB with a dash over it. Sorry, not AB, AC, my apologies, AC. This little bit right here, this would be segment AC. I can put that together with segment CB, this segment right here. If I take this little segment and I put it together with this segment over here, it's going to give me the whole line segment. From here to here, I take this one, I tape it together with this one, I get the whole line segment. I can always find a point in between two endpoints, just like it works with numbers. Could you guys give me a number between, say, 7 and 10? Give me any number between 7 and 10. 8. Can you guys find a number for me that's between 5 and 6? 5.5. Can you tell me a number that's in between 0 and 0.5? 0.4. No matter what two numbers I give you, you guys are able to name some number that's in between those. Same thing with line segments and points in between. So this segment plus this segment gives me the length of the whole segment. Down here, betweenness of points. This is what we're going to be practicing with here in just a moment. Notice their math sentence down here looks a lot like the one that I wrote up here. But what's the difference between theirs and mine? They don't have the little lines over the top. When you have the little dash over the top, that means that we're talking about a segment. Remember, I told you a line with the two arrows, that means one type of object, that's a line. A dash with no arrows means something different. I'm talking about a segment. And when we don't have any dashes at all, so like this down here, no dash over AB, what that means is this is the length or the measurement of the segment. Since line segments do not continue on forever and ever and ever, I can always find the length of a line segment. Right, down at the bottom of the page, let's practice this. Example number 1, we want to find the length of segment XZ, so from this end to this end. I see that segment XZ is made up of two smaller segments, XY and YZ. So if I take the length of XY and I put it together with the length of XZ, I get the length of the entire line segment. That's what they have written right over here. Do we know how big segment XY is? Do we have a length for segment XY? How big is it? 11.3. So we're going to write that on that line. We're going to substitute in 11.3 in the place of this notation that means the length of segment XY. Do we know how big segment YZ is? How big is it? 3.8 centimeters from here to here. So I'm going to put that in the place of the notation for the length of segment YZ. So now I add those two lengths together and it gives me the length of the whole thing. What is 11.3 plus 3.8? 15.1. All right. Let's do the check, and that's probably where we're going to end for today. Check is using the exact same ideas that we did up above, but they threw a bit of a curveball in here. What did they include on this example that makes it a little bit more challenging than the one that we just did? They have fractions on there. So I want to start this off by writing our equation, our mathematical sentence. We want to find the measurement of the entire segment from D to F. This is made up of two smaller segments. What smaller segments is it made up of? DE together with plus EF gives me the whole line segment from D to F. So if I add the measurement of DE to the measurement of EF, I'll get the length of segment DF. How big is DE? 2 7/10. So I take 2 7/10. I'm going to add that together to the length of EF, which is 5 9/10. Can I add the whole numbers together? What is the 2 and the 5 when I add those together? 7. So I'm going to add the 2 and the 5, and I get 7. Plus, and now I'll deal with the fractions. 7/10 plus 9/10. What's my rules for adding fractions? Have to have same denominator. Do my two fractions have the same denominator? Yes. So I don't have to work to get a common denominator there. I just add those numerators together. What is 7 plus 9? So I get plus 16 over 10. 16 over 10 is an improper fraction. It's top heavy. Are there at least this many up on top? All right, so I'm going to separate that into two pieces then. I keep that 7 whole number out in front, plus 10 over 10 plus 6 over 10. You guys agree that when I add the numerators, I get what I had right here? What is 10 divided by 10? 1. So I have 7 plus 1 plus 6/10. What is 7 plus 1? 8. Can I reduce 6 over 10? Is there something that goes into 6 that also goes into 10? 2. So I can divide top and bottom by 2 to reduce that fraction. What would that give me? 3/5. That would be my final answer. 8 3/5 inches. Something I want to warn you guys about. Some people will look at this and immediately turn that into decimals. With this particular one, you get a nice, pretty decimal answer. It would come out to 8.6 if you changed it into decimals. If your denominator is a difficult number to work with, like 3 or 6 or 9 or 7, you have to leave it in fraction form. You cannot turn those into decimals. All right. You guys do have your next homework assignment posted in Canvas. Homework number 2 is due on Thursday. Pages 23 to 25, 2, 4, 12, 17, 18, 23, 28, 30, 32, 35, 37, and 39. That'll be due on Thursday. Tomorrow in class, we will finish up our conversation about line segments so that you can finish up that homework. Do you guys have any questions for me before the bell? Awesome.